Welcome to the second part of differential calculus. In this part, we are going to look at the rules for differentiation. The first and the most important rule is the general rule for differentiation. This rule says that if I'm given some function y equals to x to the exponent n, to find the derivative dy dx, I simply make the exponent the coefficient and then I subtract 1 in the same exponent. Let's have a look at this in an example. Let's say you've been given some function y equals to x to the exponent 8 and you are required to determine dy dx, or the derivative of that function. According to the general rule for differentiation, I simply multiply, make 8 the coefficient of x, and then I subtract 1 from 8. Let's have a look at that. It's going to be 8 and then 8 minus 1, which is just 8x to the exponent 7. So the derivative of x to the exponent 8 is 8x to the exponent 7. Let's quickly look at some notations that we use to find the derivative of some function. You will remember this from first principles. When you're given some function f at x, to find the derivative you can simply use f prime of x. But in a situation where you are given y as your function, like in here, you can use y prime or dy dx. We also have these two forms of the derivative d dx of some function and dx of some function. We are going to use all these notations for finding the derivative depending on how the problem is presented to us. Now let's proceed with the rules for differentiation. Now I like to call this one the first rule, that says the derivative of some constant is 0. So to find the derivative of a constant, you simply put 0. Let's say you have some number, some constant 6. To find the derivative of that, it's going to be 0. If you have maybe a number like pi, the derivative of pi would be 0. And the derivative of some bigger number, minus 1,000, will still be 0. So the derivative of a constant is 0. You should remember that. Now, the derivative of a constant times a function is the same as the constant times the derivative of the function. This is the second rule over here. Now, let's have a look at this in a form of an example. Let's say I've been given some function 5x to the power 3, and according to this rule, it says that I can actually write this as 5, take out 5, it's a constant, then find the derivative of x to the power 3, which we can then simplify in this manner. The derivative of x to the power 3 is 3. I multiply by that, and then I subtract 1 from 3, then I get this. At the end of the day, I have 15x squared as the derivative of this function. Now lastly, the derivative of a sum or a difference. So if I am required to find the derivative of a sum or a difference, this is the same as finding the sum of each derivative. So the derivative of the entire sum or difference is actually the sum of the derivatives, or the difference of the derivatives. Let's have an example to demonstrate this. Let's say you have some function x to the power 5 plus 4x to the power 3 plus 3x, and you are required to find the derivative. So to find the derivative of this, it's good to remember that according to this rule, this is the sum, is the derivative of the sum, so I can simply find the individual derivatives and sum them up. in order to find the answer. So I find the derivative of x to the power 5 plus the derivative of 4x to the power 3 plus the derivative of 3x. And in that case, I arrive at this. This is then the derivative of that sum. Now let us look at some laws of rational exponents that will come in handy in solving most of the problems that we'll be facing in this part of the lesson. Now, if I have some constant over x to the exponent n, this can be written as k x to the exponent minus n. We are trying to make sure that this looks exactly like the general rule of for differentiation. So let's say I have this function here. If you look at it, I have 3x to the power 5. Now for me to be able to use the general rule for differentiation, I need to simplify this into 3x to the minus 5. Let's have a look at, if I have some nth root of some function over there, this is similar to k over that root over here. Let's say I have the cubic root of x squared. So I can actually simplify this to be 2 over 3x to the exponent 2 over 3. Now, this is just a reminder. You should be familiar with these rules. So the square root of some x to the exponent k is the same as k divided by 2. And then if I have an example over there, let's say you're given the square root of x to the 7. This is the same as x to the power 7 over 2. Let's try an example that covers all these rules or laws of the exponents, and so that you can be able to see how it works. Let's say you've been given negative 5 over x to the exponent 4, the fifth root of x to the power 3 minus the square root of x to the power 3 and a pi over 8, and you are required to find the derivative of this. Now, before you find the derivative of this function, these terms are not in the standard form. So the best approach is to use these rules or these laws of the exponents in order to find or to simplify this before you find the derivative. So we can actually simplify this to be minus 5x to the exponent minus 4. We simplify that to be x to the exponent 3 over 5. We simplify that to be x minus x to the 3 over 2, and then we leave this. From here, then we can use the rules, the general rule of differentiation, to differentiate each of these. Remember, the derivative of the difference or sum is actually the difference of the derivatives of the sum of the derivatives. So we can find the derivative of the first one. If you look at this, I multiply by 4, multiply minus 5 by minus 4, I get 20. I subtract 1 in minus 4, I get minus 5. I multiply by 3 over 5, I subtract 1 there, I get 2 over 5. And then I continue in the same manner. I multiply by 3 over 2, then I subtract 1 in 3 over 2, I'm left with half. Pi over 8 is a constant. The derivative of a constant is 0. Let's try yet another example. Let's say you are given some function y equals to the square root of x to the power 3 minus 5 over x to the power 3, and you're required to find the derivative of this function. Now remember the laws of rational exponents that we just discussed. Simplify this into the standard form for the general rule of for differentiation using the laws of exponents. Then you can find the derivative thereafter, and then you simplify that. Right. Let's try yet one more example. You've been given some function here, and you are required to find the derivative of this function. We do not have a rule that enables us to find the derivative of some brackets here. So what we do, let's multiply the brackets first to arrive here. And we know now the rules of differentiation. The derivative of the sum or difference is simply the sum of the derivatives. So here we can find the derivatives. The derivative of this one will be just 6x. The derivative of that will just be 2. The derivative of this is 0, so there's no point in writing it down here. Another example, if you are required to find the derivative of y equals to x to the exponent 3 minus 5 over x plus 1 over 2 pi, the first thing is to remember those laws of rational exponents. Simplify first, then find the derivative. Remember, the derivative of pi is just a number, so the whole thing is just a constant. The derivative of a constant is 0. Then you can arrive here. Let us now do the last example, where we've been given the fifth root of x squared plus x to the power 3, and we are required to determine the derivative of this. First thing, simplify, then find the derivative. Thank you for watching.